Good morning, class. Welcome back to my channel. Now, yesterday we were doing topics related to symmetrical figures to find the line of symmetry or lines of symmetry. So, in continuation, we start with the practice exercise. We were doing question number 4. I think two parts we had already done. Three parts. Fourth one we had to do. So there is a fourth part, there is a rectangle. So let's take a rectangle. So this is a rectangle and it has been folded vertically. So folded vertically, and then a rectangle is cut. This you have to keep in mind. You have to observe carefully that how a rectangle is cut, whether it is a square or whether it is a rectangle. This you have to see or observe carefully while cutting the paper. So here we cut a rectangle from one side and then a rectangle from other side. Can you predict what would be the figure? Well, you can easily predict in this case that figure would be like this. And there would be a rectangle over here, somewhat like this. So let's do the cutting and then see. So let's open the paper. So it is like this, and we had drawn a eye with the hole. So in this way, this is the fourth part done. What is line of symmetry? That is the vertical line. Now question number 5. Move to question number 5. Suppose you have to get each of these shapes with some folds and a single straight cut. How will you do it? So the first one is a hole in the center is a square. So hole in the center. Now see carefully, it is saying hole in the center is a square. So you have to keep in mind that when you cut the paper, it should form a square. So first of all, we take a square and then fold it. Now how would you cut the paper so that you get a center of the square? If I cut it here, so you can get it the rectangle but not the square. So that means this I would like to show here also. Like in this way, when we folded once, you got a rectangle in between, okay? But here in this part, you need to have a square. So one fold would not produce a square. What you have to do is, you have to give it another fold, one vertically and one horizontally. So when you get the another fold, now what you have to do is cut equal segments at the center. When you cut equal segment, then you will get a square. So it it is like this. Hope you this doubt is clear, that if you want to get a square, you need to have a double fold and not the single fold. So this is the square that you get in between. Okay, so this is a simple square. You gave it a double fold and then cut it equally from two sides. Now we will do the second part. Here the hole in the center is a rotated square. So first of all we take out a square figure. The center of the square is a rotated square. It has been rotated to some extent. I suppose it has been rotated to 90 degree. So now first of all we take a square. So this is a square. Now you want to have a rotated square at the center. So how would you do it? You would fold the paper once and then fold it again, as in the previous case. After this, what you have to do is, because you need corners to be along the fold, you would cut the square diagonally. Cut the paper diagonally like this, and when you open it, you would get the rotated square. So you can see here we have got a rotated square. Now what is it saying? For the above two questions, check if the four-sided figure in the center satisfy both the properties of square. So basically, to check the properties of the square, you need to measure it with scale. Okay, with ruler you would measure it. So then you would be able to find that yes, both of them are. Now this is almost 1 centimeter cut, and angle you would measure with your protractor. So you would take the protractor, keep it at one of the corners of the cutting and align it with zero line, and you would get that the angle is 90 degree at the corners. So you would say that yes, both of them satisfy both of the figure cuttings satisfy the properties of square. So in this way you get the cuttings. Now question number 6. How many lines of symmetry do these shapes have? So first is the again a rotated square. So whether it is a square or a rotated square, how many lines of symmetry would it have? Of course, how many lines of symmetry had square had? Do you remember? Hope you remember how many lines of symmetry, but we would first draw a square. Just to remind you what was the line of symmetry for square. See here, now 5 centimeters. So first line of symmetry would be when you fold it vertically, you would get the first line of symmetry. So first line of symmetry is this. One part totally overlaps the other part. Second line of symmetry had the horizontal line. This is another line of symmetry. Then the diagonals you join. The diagonals joining, the line joining the opposite corners are divide the square into two equal halves. So there were 4 lines of symmetry. Similarly, in this case, what has been changed? Only the sides have been changed. Corners are 90°. So you need to just draw a square with corners 90°. But in this case, you have rotated the square 90° rotated the square. So you need to keep in mind that figure only. Rest would be, let's see what's the case. Now suppose first we join the diagonal here, opposite corners. So you would get the first line of symmetry. This is first line of symmetry. Because the upper portion, when you fold it, it would totally overlap the lower portion. Then you have the diagonals here. You have the second line of symmetry. The second line of symmetry would also divide the square into two halves. The left hand side half would totally overlap the right hand side half. What else? How can you divide this square? You can divide it by folding the mid of the sides. First we folded it along the corners. Now we are folding it along the sides. So one third line of symmetry is this, and the fourth line of symmetry would be the other two opposite sides. This would be the fourth line of symmetry. So the given figure has 4 lines of symmetry. Now we draw the second figure. So how would you draw the second figure? It is now the difference between the figure is that in between you have symmetrical two sides like this. So this is our figure, part B, question number 6. Okay, so this is the figure. Now you have to determine the lines of symmetry. So how would you start? First of all, we can start from any side. Say here, this is the corner. Then you look for the opposite corner. So first line of symmetry would be joining the opposite corners. This is line of symmetry number 1. Then we move to this edge which has been reshaped. So if I draw an edge horizontally here, then half portion of the paper would overlap the other half. So that means this is the second line of symmetry. Then we come to this corner. This corner also has opposite corners. So this is the third line of symmetry. Then you get the edge out portion. This is the fourth line of symmetry. When you overlap the left side, it would superimpose the right side. So I think this is with it. You have total 4 lines of symmetry in the figure. Now you have been given question number 6, second part. Let us see what is a triangle with equal sides and equal angles. So you have to make a triangle with equal sides and equal angles. So let's make a triangle. First, a 5-meter base. Then what would we do? We would divide it is 5-meter base. We would take the midpoint of the side. Okay, midpoint. That is, if it is 5 centimeter, the midpoint would be 2.5 centimeter away from the ends. So at 2.5 centimeter, you put a dot. Then what you have to do is draw a standing line. Now you can take a compass or a ruler, and you need equal sides. So that means you have taken 5 centimeter. So you would take the 5 centimeter that would cut this line 5 centimeter. So you would draw the line as such 5 centimeter here, and the third line would automatically be 5 centimeter. So this is how you get a triangle with equal sides. See how I have constructed. You can trace the triangle also, but if you want to draw it, then this is the method. First you have to draw the base of the triangle, then take the midpoint, which is 2.5 centimeter, draw a standing line, and after that this side is 5 centimeter. So you have to draw one side which is 5 centimeter and cut this standing line. Similarly, from the second corner you should have 5 centimeter line which cuts this standing line at 5 centimeter. So in this way you can do it. Other method is you can open the compass of 5 centimeter, then draw. Let me show you the second method. It would be easy for you to draw with ruler, so that's your choice. But for you open the compass 5 centimeter and draw an arc over here. Similarly, you draw another arc which cuts the previous arc. So this is a triangle with equal sides. This is another method. So it's your choice, whatever method you use. You need a triangle with equal sides and equal angle. If a triangle has equal sides, it would have equal angles also. Such types of triangles are known as equilateral. Equi means equal and lateral means sides. So equilateral or equal sides. Lateral means sides. So you have equal sides of a triangle or equilateral triangle. Then you have to find the line of symmetry for this. Now what would you do? How would you find the line of symmetry? You have to find the midpoint of all the sides. This is 5 centimeter base I have taken, and other sides are also 5 centimeter. So what you have to do is find the midpoint. So this is at 2.5 and join the opposite corner with the midpoint. So you would get the first line of symmetry. Okay, so this we would do with paper cutting also, so that you understand it properly. So let's make a equilateral triangle. So first line of symmetry you have got. Now we have to find the other line of symmetries, lines of symmetry. So it is like this. When you fold the midpoint of this side along the corner, you would get the first line of symmetry. The one portion is exactly overlapping the second portion. Okay, so this is the first line of symmetry which we have made, the vertical line of symmetry in this case. Then how else would you get the line of symmetry? If you fold it along the second corner. So this is the first corner, this is the second corner, this is the third corner. So if you fold it along the second corner, then also you would get the line of symmetry. So I am giving it here a name: first corner, second corner and third angle, you can say. So now let us fold it along the second corner and you would get the side with equilateral. This is the second line of symmetry. Along the corner you have folded, one portion gets folded over the overlap the other portion. So this is second line of symmetry. So let us keep drawing the line of symmetry here also. Then what is the, so my second line is like this, somewhat like this. This is the second line of symmetry. Then what would be the third line of symmetry? When you fold it along the third corner. This is the third corner. So I fold it along the third corner and I would get the third line of symmetry. So this is my third, just a minute. This is my third line of symmetry. One portion is totally overlapping the other. So third line of symmetry when we get, we draw it over here also and you get the third line of symmetry. So in this way you can see that in the triangle with equal sides and equal angles, we have three lines of symmetry. So in this way you get the lines of symmetry. Now come to the third part. Third part is a hexagon with equal sides and equal angles. This we had done before earlier also in the first class, I think. In the first class of symmetry, hexagon is also done. So let's do it fast here. I will give you the link of that class. You can see from there that how to get the line of symmetry for a hexagon with equal sides. For drawing the hexagon with equal sides, we would take first, let's take it 4 centimeter side and then we make it with compass. How to draw a hexagon? Just look over it. Compass, open the compass for 4 centimeter and first draw an equilateral triangle. So you get first triangle here. So this is my first triangle. Let's join it. Now you need the second. This is the first side of 4 centimeter of hexagon. For getting other sides, we would keep drawing it equal to 4 centimeter and cutting the arc from center. This is the center of hexagon and from this corner of hexagon I get the second cut point. So see it carefully. One corner is taken as the center of the hexagon and second is the corner of the side. So you get the hexagon like this. Then again what you have to do, hexa means 6, gon means sides. So it is 6 side figure. Like square you have 4 side figure. Similarly for hexagon you have 6 side figure. So you have to draw 6 sides total. So this is my third side. This is the third side. Then we draw the fourth side. This is becoming the center and this is becoming the side corners. Okay, this is the center and these are the side corners. So one arc from center and one arc from side corners. So you would get the hexagon like this. So this is my hexagon with equal sides. So these are the sides. 3, 4, 5, 6. The marking is done like this for equal. You have already learned this. Now what are the lines of symmetry here? Lines of symmetry are, you can see here that I can fold the hexagon along the corners. When you join the corners, you get the lines of symmetry. This you have learned from now square also, from triangle also, that not triangle but from square, that if you join the diagonals or a rotated square, you get the lines of symmetry if you join corners. So there are total 3 lines of symmetry from the corners and 3 lines of symmetry from the sides. So you would get like this: 1, 2 and 3. So in this way you get total 6 lines of symmetry. What has we done? We have joined the corners and we have joined the midpoint of the sides. So you get, whenever you fold it along one of the line of symmetry, the other portion would overlap the first portion. First portion would overlap the second portion. So I think it is, I wrap up the class here only. We will do next questions in the other class. So have a nice day. Take care, students.